Hi, I'm Yann Boulanger. You may remember me from such conferences as Who is hot? Climate change is burning issue, or Caribou are doomed. Let's eat them all. But today, I'm here to talk about timber harvesting and climate change are predicted to reduce future habitat suitability for boreal caribou in Quebec. So this is not a surprise for anyone, and Earth is warming at fast speed. In Canada, for example, warming is occurring at twice the pace of the rest of the globe, and we're talking about 1.7 degrees Celsius of warming since 1948 on average. But in some regions, notably the Northwest, it's more than 4 Celsius during wintertime. And this warming will continue and accelerate in the upcoming decades to reach 4 to 7 degrees Celsius warmer than in 2000, depending on the climate scenarios in Canada. And precipitations will also increase, but not that much, so it won't be very different between scenarios. And as such, climate will be much drier. The Canadian forest is already feeling indirect and direct impacts of climate change, and we're talking about increase in fire activity, change in insect outbreak regimes, more common drought, change in forest productivity, etc. So the impacts are felt on ecosystems, but also on the forest sectors. And all Canadians have the potential to be affected at some point. So these impacts are diverse, they vary geographically, they are complex, they often accumulate, and they also interact with each other. So no doubt that these impacts will be exacerbated in the upcoming decades as climate is further changing. But how all those impacts will interact and accumulate to change forest landscapes? For example, what will be the cumulative impacts of fire, spruce budworm, but also the initial conditions, seed dispersal, for example, that might make forest stands to change? And also how harvesting strategies will interact with climate-induced changes in forest landscapes. So impacts are likely to be different between regions. So we need a spatially explicit way to analyze the results. So from previous studies, we have shown that the boreal forest was probably the forest region in the Quebec province that was most likely to change in the future. On these maps, so the more there's orange or red, so the more there are changes. So you see that other forest regions, such as the mixedwood and temperate northern hardwoods, will also change, but not as much as the boreal. And these changes in boreal will mostly result from important increases in fire activity, especially in the northwest, which will cause landscapes to get much younger while favoring the regeneration of deciduous pioneer species such as trembling aspen and white birch, for example. In 2012, the Environment Canada published the recovery strategy for boreal populations of woodland caribou. And as these are, there are important conservation concerns about the species across its entire distribution. So landscape level planning, including the reduction of anthropogenic disturbances such as harvested patches and roads, for example, were identified as essential steps for the successful recovery of the species. But however, the recovery strategy for boreal caribou is relatively quiet about the impact of climate change on these recovery actions. So as we've seen from the previous slides, climate change is likely to strongly impact key woodland caribou habitat features. For instance, increases in wildfires could increase the availability of early several stands of deciduous trees, which are most favorable to alternate prey, such as moose, at the expense of old-growth conifer stands, which are preferred by caribou, for example. And further temperature increases in southern part of the boreal caribou distributions where the remnant populations are on the brink of extinction after decades of anthropogenic pressure would also favor warm adapted deciduous species at the expense of boreal conifer stand used by caribou. So within the commercial forest, climate-induced changes in caribou habitat could interact and accumulate with timber harvesting and other human activities, threatening boreal caribou recovery. Yet, it remains unclear how current conservation strategies will perform under rapid climate-induced change in forested landscapes, but this knowledge is urgently needed to refine recovery action for species at risk, such as the boreal caribou. So in order to study all those interactive and cumulative impacts, we use the forest landscape model LANDIS-II, which is able to simulate processes occurring at both the stand and landscape scales. For example, it simulates regeneration and growth at the stand scale, while it simulates natural and anthropogenic disturbances and dispersal at the landscape scale. So we can also integrate the impact of climate change in some of these processes, like we simulate all commercial forests in Quebec under 3 different climate change scenarios and under 2 forest management scenarios. So the climate scenarios were historical climate, the RCP 4.5, which is a moderate greenhouse gas emission scenario, and RCP 8.5, which is an aggressive emission scenario. And the 2 management scenarios were current harvesting strategies in Quebec province, and the other was, well, a highly theoretical one, was no harvesting at all. So we can see the difference between to have conservation strategies. We then used the habitat suitability model developed by Mathieu Leblond in 2014 to translate the projected forest landscape characteristic by LANDIS-II into specific forest covers that are important for boreal caribou habitat. So we combined climate-induced changes in those forest covers with anthropogenic features on the landscapes, like forest roads, for example, to express these results as quality habitat indices in each of the 10 populations identified in boreal Quebec. So now let's see the results regarding the changes in specific forest cover for 2 very contrasting populations. Asinica, where fire is and will be an important driver of forest landscape, and Manicouagan, where fires are much less important. So each line on the graph, I mean the line of graph, represent harvest scenarios. So with current harvesting strategies at the top and complete conservation at the bottom. And each column are the different climate scenarios. So with climate change, what we see is that stands that are considered as natural disturbances are increasing greatly in Asinica, but also in Manicouagan, but to a lesser extent. And this increase is done at the expense of old conifer and mixed stands preferred by caribou. And with harvesting, these old conifer and mixed stands are rapidly decreasing in both regions, while regeneration and, of course, harvested stands are much higher. So on this slide, we have a better view of where old growth conifer stands are likely to change according to climate and harvesting scenarios in 2100. So under current harvesting strategies, these stands are likely to decrease in brown almost everywhere, but especially in the Northwest, where fire will increase the most. If we stop harvesting, these old growth conifer forests increase, but mostly in the Northeast, even under increasing warming, actually. When we take all forest covers into consideration, as well as fixed features, such as roads and mines, for example, we can calculate the habitat quality indices for the territory. These are the results for this index under RCP 8.5 when we are considering harvesting. So we see that under this scenario, habitat quality is decreasing, and patches with high quality in blue, they are vanishing rapidly, except in the Northeast, where some of them still remains in 2100. If we stop harvesting under the same climate conditions, so under RCP 8.5, conditions are improving or are at least stable in the Northeast. But there is an area in central Quebec, in red, where stopping harvesting has no impact at all on the habitat quality, which stays very low. This area actually will experience a lot of fires in under RCP 8.5, but is also already covered with a lot of roads, which are maintaining the habitat quality very low. So when we are looking at the variation of habitat quality indices according to climate and harvesting scenarios for each population, we see that conservation halts climate-induced decrease in habitat suitability, but mostly in areas where fire activity won't increase too much, like in Manicouagan, Nolaway, Côte-Nord-Sud. And as said before, the there's small impact of stopping harvest in regions that are already very degraded, like Charlevoix and Val d'Or, and some populations in central Quebec. It has very small impacts. But what is more important to explain variation in habitat suitability? So it appears that timber harvesting was the most important agent of change, explaining caribou habitat suitability at the beginning of the simulation. So you have harvest importance in broken lines and climate importance as dotted lines, and each of the climate scenarios are in different colors. So, but however, the importance of climate change tended to increase with time. Still, harvest remained the most important factor for the great majority of populations up to 2060, regardless of the climate scenarios, actually. But beginning in 2060, however, climate change became the most important agent of change for populations located in the north central part of the study area, like Portneuf, Pirot, Basinica, Témiscaming. On the other hand, harvest remained by far the most important agent of change for the two populations located in the northeast part of the study area, like the Manicouagan and the Côte-Nord-Sud. So we know that forest roads are an important factor contributing to the decline in caribou habitat quality. So what would then happen to these indices of habitat quality if we are to decommission these roads along with stopping harvesting, even if we are under climate change? So this would be, of course, a very highly theoretical scenario, but decommissioning all the road would allow us just to see in the simulations what would be the impact of forest roads actually on caribou habitat quality under climate change. So here you have a map depicting the difference in habitat quality in time between the worst climate conditions, so under RCP 8.5 and with road decommissioning, and compared to business as usual management, so as we are doing today, under the best climate scenario, so the historical climate. So it means that even under RCP 8.5, we see that road decommissioning would help improve habitat quality by a great margin. So everything that is in blue is actually improvement. So compared to today's climate and today's harvesting strategies. So in a nutshell, so we see that the combined impacts of timber harvesting and climate change has a significant impact on significant decrease in habitat suitability for boreal caribou over the horizon that we have studied. And timber harvesting was the main agent of change explaining habitat quality for caribou at the short and medium term, so up to 2060 approximately. And the increase in climate forcing accumulates with harvesting to further decrease caribou habitat quality. So current harvest levels might not seem very sustainable for caribou habitat quality throughout the province. So even mild, when I say mild conservation measures, it means that only stopping harvesting, so not road decommissioning, might not be sufficient to efficiently restore caribou habitat under climate change. But the dense road networks and other anthropogenic features that prevent habitat quality to improve regardless of the climate scenarios, as we saw in the north central Quebec. So the recovery strategies that do not consider reducing the impacts of permanent features like forest roads are likely to fail to improve habitat quality in highly outer regions. So thanks a lot, folks, and I'll be there to answer your questions. Thanks.